Let's talk about the point-slope form of a line. If you have a line containing x sub 1, y sub 1 with slope m, the equation for that line is y minus y sub 1 equals m times x minus x sub 1. And we call that the line in point-slope form. The point is x sub 1, y sub 1, and the slope is m. We can use different letters for the point and the slope. We could call the point h comma k and the slope a. Why would we do that? When you get to quadratics, a quadratic in vertex form is y minus k equals a times x minus h, the quantity squared, where the vertex is h comma k. And h comma k and a are the letters traditionally used when you get to quadratics, so that we have a parallel structure and that we see the two are very similar when it comes to transformations of functions. We'll use this form here, y minus k equals a times x minus h, which is a line containing the point h comma k with slope a. Now let's consider a special case of the point-slope form, that is when h is equal to 0. So we rewrite y minus k equals a times x minus h. When we let h equal 0, x minus h simply becomes x, so we get y minus k equals ax. If we add k to both sides, we get y equals ax plus k. That should look familiar. Most often you've probably rewritten that as y equals mx plus b. A and m are the same thing, k and b are the same thing. A is the slope, k is the y-coordinate of the point when h is equal to 0. But if there's a point where the x-coordinate is equal to 0, that is a y-intercept. So y equals mx plus b, or y equals ax plus k. A is the slope and k is the y-intercept. Here I've graphed y minus k equals a times x minus h. Let's let h be equal to 1, k be equal to 2, and a 3. If h is 1 and k is 2, then the graph should go through the point 1, 2. 1, 2, in fact it does. It has slope of 3. As we go from this point to this point, we rise 3, run 1, so it has a slope of 3. And we verified that this is the graph of y minus 2 equals 3 times x minus 1. Let's take a different example. If we let h be negative 1, let's let the slope be negative 2, and let's let k be 1, then this should go through the point negative 1, 1, negative 1, 1, with a slope of negative 2. As we go from this point to this point, we rise negative 2 and run 1, so the slope is negative 2. Now let's consider a special case where h is equal to 0. When h is equal to 0, it does go through the point 0, 2, 0, 2, and has a slope of 3. So if we start with y minus k equals a times x minus h, and we substitute in the values for this particular case, we'll get y minus 2 equals 3 times x minus 0, which is equivalent to y minus 2 equals 3x. Adding 2 to both sides, we get y equals 3x plus 2. These two equations are two different ways of writing the same equation. The top one is in point-slope form. The bottom one is in slope-intercept form.